So we're back in Unity. Alright, so let's try to get back where we were, which is this depth shader. So now let's upgrade this a little bit. Like now it's like expanding it like into infinity, right? Now the question would be something like, can we make it like regional? Like we're gonna cut it out if once we hit the edge. So let's do that. Let's see. Queasy specific. Depth. There we go. Oh boy, I used the wrong stuff. This may take a while. There we go. Wait, this does not look right. What is this? Oh, 2.0? Okay, this is not the thing we're looking for. Alright, so let's close that thing. Anyway, let's head back here. And then what I should have done is actually right click on this. And then show it in Explorer and then open it up. Then it should be good. Specific depth. There we go. Excuse me. And then let me bring this thing to the left. And here we are. So basically, let's do something like let's say out color. So out color, it's a color. For now, it's gonna be black with an alpha of 1. There we go, and then go. It's a fixed 4. So out color. There we go. Alright. So here we have this. Which also works. Delta X, delta Y. Okay. So let's say we are going to have a float 4, or maybe I should say fixed 4, and then let's call this final color. Okay, and then we are going to say final. Oh wait, I shouldn't say as final color. We should say get color. Get color from depth. Hold on a second. Because I'm thinking all we need to say if delta X or delta Y is out of bounds, any of them, then we'll just paint it the out color. Alright, so fine, let's go back to fixed 4. Final color. If, okay, I dot uv dot x plus delta x is bigger than 1, or I dot uv dot y is bigger than 1, or they are smaller than 0. Smaller than 0. Smaller than 0. Oh wait. Okay. We also need to say float 2. Let's say total UV is this thing. Because we know that this is correct. So there we have it. So to put this in another word, it would be something like if total UV of x is bigger than 1, or total UV dot x is smaller than 0, which is out of bounds, or total UV dot y is bigger than 1, or total dot UV of y is let's see, smaller than 0. Then these are all out of bounds colors, so final color will be out color, else we will get text to the main text, and then this time we're going to grab it from total UV instead of in UV, and then we will just say return final color, and then over here we have to say that final color is this, then we'll return that. Let's see if it works. Oh boy, there we go. Ah, there we go. Oh, 151. There we go. So let's head back here. Now we have this. And yep, that's our depth. So to make it much clearer, we can choose other depth colors. For example, red or whatever. Oh! Okay, that almost looks sus. But anyway, it looks fine. So we have that. Now, let's see. So we have this thing. Now the problem would be something like, or the question would be something like, can we have multiple layers? If yes, then let's see. Oh wait, also, let me try this. So, go back here. Since we are looking at from an angle, we can easily see there we go, it works pretty well. But let's just say we let the user choose if we want to use this like boundary check. So what we can do here is, let's say we're going to use a float again. Float, no, hold on. There we go. There we go. And it's arranged from 0 to 1, and by default it's 1. So bound check. And then here we go, float, bound check, there we go. And now over here, and all of these needs to be end with that. Bound check is not equal to 0. So let's get back here. Now use boundary, yes. Otherwise, boop. Yeah, we can do that. It's actually quite cool. Okay. But anyway, today's new topic would be something like, can we use screen space stuff? So let's quickly do that. Alright, so let's copy and paste something out of nowhere. In this case, this thing. And then let's call it screen. Also, there we go. So basically we are kinda done with this. So let's close this. Let's see. Aha, there we go. Let me open it up. There we go. And then over here, let's call it screen. There we go. And then save. There we go. And then this thing, we'll be using the screen. Alright, so now we have this to start with. Now, we go down here, we have that. Okay, let's see, because I found something quite useful when it comes to like getting the screen position. So we have this one over here. So to get screen position is actually vertex and then compute screen pause. Oh, wait a second. Oh, we need some sort of like unity matrix MVP. Do we have that? Let's see. We are using Unity object clip posts. Is this good? But anyway, let's get rid of this. Okay. Let's see. Outgoing. Oh wait. Okay, what we need is this. So float something. Is it float to screen position? Let me take a look. Alright, so the float to screen pause. That's what we would call it, alright? Hex chord 6. Let's have this. So screen pause. Now, screen pause. We will have it here. Dot screen pause is first we need mul and then unity matrix MVP, and then we will have where is it? Incoming. Yep, that's incoming, and then vertex So we have that. First we have this. So then we will say compute screen pause. Okay. Compute screen pause. And then we have that. And then we have that. Not quite sure if this will run, so let's check. So let's return float for hold up, let me remove this. There we go. I dot screen pass dot xyz and then 1. I don't know. Maybe it will work, maybe it will not work. Let's see. Probably we'll get a few shader errors. There we go. So what it says: invalid subscript xyz. Fair enough. My bad. There we go. Oh my goodness. Oh wow. Look at that. Look at that. So we have our screen position correct. Okay, cool. Now the problem would be something like, how can we know? Okay, like this is 0 and then 1. And then what's over here? Like we have 0 and then 1 and then what's next? So that would be my question. However, it's a little bit too bright, yes. But if I were to like shrink, alright, let's do this, and let's do that. So we have this. And yep, it is screen spaced. Or is it like 0 and then 1 over here? Huh. Could be. Alright, let's, you know what, let's turn up that volume. There we go. That's weird. Is there anything I'm missing? Let's see. Compute screen params XY. Huh. Multiply by that. I believe it's like self-built in. Right? Alright, let me take a look at that. So let's bring this thing up. And then green post equals this thing. Multiply by that. So let's come up here. Oh. That's strange. Oh wow. Now it's pixel base. I can see a little bit of red down there. I don't know if you guys can see it on stream, but I can see a little bit of red down here and a little bit of green on the left hand side. So it's now pixel based. Oh wow. Okay, you know what? Let's do something funny. First of all, let's have screen adjust. Okay. Screen adjust. And it's a vector. By default, 1111. And then down here, alright, let's get rid of that. Float. Or no, it's a vector. Screen adjust. There we go. And then multiply by screen adjust dot xy. Yeah, so we have that. So if we get back here, then we can cheat ourselves way into this thing. So let's get back our plane. Now screen adjust. Let's go for 0.5. Beams working. Okay, another 0.5. Okay, that seems odd. Alright, 0.01, 0.01. Aha! We're getting there. Something like 1,000 or something. Almost there. Okay. Okay. We're getting there. And it actually looks... Oh boy. Perhaps that worked or maybe not. Alright, needs more. 0.001. Adding a few more zeros. Wait. Where did that went? Alright, perhaps that's too much. Now the strange thing is, it just keeps on like not masking the correct stuff. So that's the sad part. But let's see. So 1, 2, 3, 1, 2, 3, 5. when I rotate, when I orbit around. That's a bit weird. But anyway, let's get back to Unity. No, the code. Let's say let's say I just picked the raw thing from out of nowhere. Let's see what will it give us. Oh, now this is something interesting. Vertex. What if instead of this we say it's this? Because oh wait, then it would be the same as Unity object to clip pose. Yeah. You know what? Let's dig in Queasy Shader Tree again. And let's see what we can grab from there. So if we were to take a look at builder and we'll pause. Oh wait, I almost forgot to announce that Queasy Shader Tree, which is this thing, now can detect your distance, so you can do distance fading. I almost forgot to mention that in the last stream. Anyway, what can we grab from here? In this case, let's take a look at our vert function. There we go. So over here we have this Unity object to clip pose. Oh, also, yesterday, I go to Wikipedia a little bit, and then I check dot product, and turns out there's a lot of code over here which can be compressed into like dot products. So maybe I'll take a look at that. Anyway, we know that screen pause is like kinda working, but not quite. Wait, did it update something? Replace this with Unity object to clip pose. Oh, so that's what it was? If we take a look at this thing over here, position. Okay. First distort, then clip pose. Okay, so that is actually one of the mistakes I've done in the past, because I clip pose it, then normal distort it, and then it becomes weird. Unity object to load. Whoops, space builder. Okay. So if we take a look at this again. No idea what went wrong. Let's crank this thing up back to 1. So let's have this. What about if I say ZW? It will definitely look weird, but let's see how weird it is. Oh, it's actually... I wasn't expecting that. Okay. Then... let's bring back this. Then... oh wait. Instead of that, let's have a slider. So... it's a range from 0 to 1, and by default it's 1. Let's copy and paste this thing. X and Y. Okay, so we have that. Now, if we were to come back down here, it's not a vector, it's a float. Screen at just X and screen at just Y. So we have that. So let's have a float to X and screen at just Y. So we have that. And then let's come back down here. Now we have this, which this thing, like in orthographic it looks fine, but here no. So yeah, we somehow get it, but if we were to zoom back to 1 and 1, then we'll have that. This is something I don't fully understand. But this is what we have to get the screen position. Well, since there's nothing much else we can do here, let's try to compress this thing. But before that, let's make a material out of it first. So let's bring out our sphere, plane, turn it off. Alright, there we go. Now for the sphere, it's also that. Now let's choose this and let's choose that. Now definitely it will start burning our eyes at the very beginning. So let's turn that off. Let's turn that off. Just in case if you're wondering where's the distance fade, here's the distance fade. Oh, also let me do this. There we go. Now we can see better. Also focus, so we can have a smaller drag or hierarchy. Let's bring this thing back. There we go. Giving myself a head pat. Alright, anyway. Main texture. Get influenced by Wenzel. Yes, we want that. And then so if we go down Wenzel, there we go. Intensity, crank it up. Ramp. So we know it is still working. If somehow went wrong, then we know it would turn into magenta, and we can try to fix it. So let's see, like where we can use dot product, because what dot product is like, multiply those entries and then add them up together. And I realized that a bunch of stuff over here actually uses dot product. Let's see. Oh, there we go. Distort total. Adjust. Here we can see exit distort x plus 0. So let's do that. Dot. Let's call it dotify. And then let's call it here. So in dotify, so we have this to here. So here we have a float for, we call it axis distort total, which is another float for. Bracket it out. Oh wait, no. Bracket it out. Then we have this. Let's take axis distort x plus 0, which is this thing, and then let's dot product it with axis distort axis distort x power, which is this thing, axis distort x power. So dot product of that, and then afterwards we need this. Adjust. And then we can do the same stuff for the others. And that one is 0. And this one should be Y. This one should be Z. This one should be Z. This one should be Y. And then this one should be Y. This one should be Z. There we go. So also semicolon for that, so let's save this. So let's head back here. This may take a while for it to load. There we go. I think perhaps we are in good shape, maybe. To check, let's bring in a texture. And let's say, okay, although it is influenced, let's make Fresnel a little bit. There we go. Or, you know what, maybe not. Fresnel influence 0. So we have this. Now let's check our vertex. Vertex distortion. Let's check Y. So in this case, let's choose purlin, and then distort amount. Let's go with 1. Okay, so it actually kind of works. So yeah, we have that. Good. So we know it's working. Okay, so let's get back here. So yeah, this thing is working. Or just need to make sure if this is 1, then distort adjust. Yep, we have that. Cool. Alright, good. So this is 0. And then let's go with 0. Okay, so let's get back here. So we know this thing is working. Poof. So that has been compressed into this. Okay. First, it's a incoming vertex, but in object space, right? And then axes distort total, norm distort, and unity object clip pose. Okay, so here is like object space, and then it will be float space. Or is it unity object to clip pose. Let's check how would they say it. Unity object to clip pose. Let's see what it does. Built-in shader helper functions. So we have this. There we go. Transform a point from object space to the camera's clip space. Okay. Okay. Alright, just need to make sure if swizzling will work here. Okay, if swizzling works here, then I can compress the rest of them. Ah. Let's see. Data number 3. Let's see what it says. No matching. So swizzling will not work here. Okay. There we go. while. There we go. So yeah, swizzling will not work in that case. Alright. So, let's see. So over here we can see norm distort pass 1, non distort pass 0, norm distort pass 0, norms distort pass 0 as well, but norm distort power R, and then power G, B, A, and norm distort amp. Oh, that's the amplitude. Alright, so let's dotify that. And just in case, dotify is not a real word, it's just a word I came up with. Go. So, I say float norm distort past 0. Oh wait, it's 1. It's actually dot product of something. In this case, norm distort past 0 with another float 4. And then these float 4 are these. G, B, A. And then so norm distort power A, and then afterwards take the dot product and then just like multiply amplitude. So let's see if this will work. So this is norm distort. Basically, it's actually normal extrusion. So let's test that. So let's pick up this thing, and then normal extrusion, black matte layer, vertex distort, vertex normal extrude. We need purlin. This thing. There we go. Let's say red always have a duration of that. Red string 1 1 amplitude 1 up. There we go. If we use 1, then we can roll it whatever. So yeah, we know it's working. It's just the frame rate is a little bit low. No idea why, but probably because of the stream, and you know, it's actually a slightly complicated shader for this one, but good enough. So we know it works. Okay. So we can remove that. Okay. So got that. Now we can go down here and see. Okay, this looks suspicious. Okay. Pixel 1 dist R, and then texture layer 1 this power R dot X, and then G dot X. Okay, so this cannot be dotified. Okay. However, I have a feeling that the masking power can be dotified. Because if we take a look at this, you can actually dotify this thing. So we can say pixel 1 mask power. It's actually dot product of pixel 1 mask 3, pixel 1 mask 3, and then a float 4 of those stuff. Which is this thing, and that thing, and this thing. So we have that. So R, G, B, A. So we have those. Texture layer 1, mask pow. So we have those. Then we can remove this. And then we can copy and paste the same thing. There we go, which is this thing. So layer 2, layer 2, layer 2, and layer 2, and then pixel 2, pixel 2 mask 3, pixel 2 mask power. So we can remove this thing. Let's take a look at this. So if we were to remind ourselves like why we have like 4 separated parameters instead of 1 vector, let's take a look at the control panel for the masking layer. So if we take a look at the masking layer, which is way up here, store texture, mask. They're all sliders. Red is mask, green is mask, blue is mask. These are all powers, I believe. So yeah, they either have 0 or 1. They have a range. So yeah, sadly, when it comes to like vector or float 4, they don't have a range. That's a problem. So yeah, I'll go stick with that. Anyway, let's go downwards. Sizzling will not work when it comes to like self-defined stuff, so not gonna do that. Oh. Ah. Yep, the distance is over here. Alright. What else can we crunch? The vector. Oh. Ah, here we have another one which can be dotified, I believe. Let's see. Yep, it's something that can be dotified. So let's do this. Vector 1 plus. Oh wait. Vector CR 1 plus 1 of 3. Vector CR 1 plus 1 of 3 is dot product of vector CR 1 plus vector CR 1 plus 1 of 2. So it's vector color 1 and then plus 1 of 2. Wait, vector color. Oh, this means we have 4 of them to deal with. Okay. We have that. And then we have float 4. And then we just need to copy and paste the rest. And then green, blue, and that. And it has a range from 0 to 1, that's why they're separated. So we have that. Vector CR 1 plus 1 of 2. So we have that. And then each entry is RGBA. Alright, so we can get rid of that. One pass of 3. Baseline. 1 pass. It's actually calculating the mask power. Alright, so let's copy and paste that to the other vector colors as well. Alright, let's see. Up there we go. So, vector color 2, pass of 1, okay. Vector color 2, layer 2, vector color layer 2, color layer 2, vector color layer 2, and vector color layer 2. And then we can remove this thing. because this has been dotified. That's what I would call it from now. Vector CR layer 2 must POW A. Now the other one would be this. Paste. And this time is vector color 3. So vector color 3. Vector color layer 3. Vector color layer 3. Vector color layer 3. And one more vector color layer 3 must POW A. Get rid of the rest. There we go. So that's one thing. And then finally, this one over here, which is number 4. So vector color layer 4, and then number 4, number 4, number 4, and number 4, and then number 4. And then let's get rid of what's on the top up here. Let's get rid of that. So now let's test all the vector colors. So hit save. Alright, now let's get back to Unity and then test the vector colors. This may take a while for it to load. There we go. So let's not use normals for now. So let's take this thing. Let's say none over here, and then 0. Alright. 1 1. Oh, okay. Store amount. Vertex. None. And then distort amount. Amplitude is 0. So we have that. Now. Oh wait, if we say this, then we say that. Yeah, then it's correct. Okay. Alright, now let's focus on vector color. So let's see, vector color 1, let's say it's red, and then it's pointing from 1. Oh wait a second, I also need to say it can be influenced by vector color. So vector color influence is yes. And then force alpha, yes. So let's go back to vector color strength is now 1. Okay, so now we know it works. Now the next one is green, so 120. And then pointing from Y, and then strength is 1. So we know that is working as well. And then now let's, oh wait, what if we go with 0.5? Yeah, well let's stick with 1. And then finally, this one over here. Let's go with 420. And then you have that. Wait, do we choose 420? There we go. Alright, and then we have a strength of 1. Also pointing from the Z direction. So we have that. Now just need to make sure that the final direction works. Let's choose a color whatsoever, yellow whatsoever, and then let's just go with -1, -1, and -1 with a strength of 1. So we know it also works as well. Alright, so we'll have that. So we know vector color layer is working perfectly fine. And the frame rate comes back for no reason at all. Alright, also, let's see. What else can be dotified? Oh, the next thing is Fresnel. Ah, Fresnel mask can be dotified. Okay. Yep. Here we are. So if we take a look at this, then we know immediately if we were to line them up, then we know it can be dotified. Alright, so fresh no 1 mask power. Fresh no 1 mask power is dot product of okay. Fresh no 1 pass, oh boy, 4 of 2. So we have Fresnel 1 plus 4 of 2. Alright, and then we have float force, which are these. So let's copy and paste those. Paste but G, paste but blue, and paste but alpha. So we have that. So we have that. Okay, this means we can remove this. And then also let's copy and paste this thing, because we have several of them. In this case, Fresnel number 2 needs it, so let's paste it over here. Layer number 2. Just need to make sure that we're getting right. Layer number 2. Layer number 2. Layer number 2. Finally over here, Fresnel number 2 plus 4 of 2. There we go. Although this past 4 of 2, this off over here, it's grammatically and logically wrong, but I believe you guys know what it means. It's almost something like the dot operator. But yeah. Anyway. Okay. Fresnel 2 plus 4 of 2. 4 of 2. 2. Alright, let's get rid of that. However, Fresnel, not 1, but Fresnel 2. Mask power. So, Fresnel 2, mask power. So we have that. Fresnel mask power. Is it like Fresnel mask power? Oh, there we go. Color mix. Okay. Fresnel 1 mask power, Fresnel 2 mask power. So we have Fresnel pass number 3, pass number 3, Fresnel 1 mask power, so we have that. And then also over here, Fresnel 2 pass 3, third pass, and then we have the mask power over here. So we're good. So let's hit save. So to check if this thing works. Alright, so let's go back up here and say it's not influenced by vector color anymore. So let's hit 0, let's hit 0. Now it's infected by or influenced by Fresnel or Fwenzel. So let's take a look at this Fresnel layer. We have number 1 over here. Now mask it with something. In this case, let's go with Perlin again every time. And it seems like it's working. Now, red is mask whatever it is, so make the others 0. And then we have this. So yeah, it's working. Now, let's take a look at this. Glitter. Alright, I think we have dotified almost everything. And then the rest are slightly complicated stuff. Yep, alright. Now, what are the things that we can dotify? I don't know. Oh wait, hold on a second. Also, we can also do if-else optimization for vertex distortion, right? So let's take a look at that. Oh wait, there we go. Now over here, oh wait, we don't need the screen shader anymore because we are not going to work on that. There we go, split window, and then now let's go down here, and here we are. All right, let's take a look at this. Power, distortion power. Okay. Distortion power, and then we have power adjust. Alright, I think I know what we need. So over here, let's like define it first. So in this case, let's have a fixed 4 axes, distort x plus 0, distort x plus 0. So we have that. And also this is y, and then this is z. Now we have these, and then we will also use the if-else statement. So if this power thing over here is bigger than 0, then it will do something. Or I should say, if it is 0, else it will do something. So if it were to be 0, then we know that this thing is like, it doesn't matter anymore. So Control C, Control V, there we go. This will equals a float 4, and then all zeros. Otherwise, what would have happened is this. So let's cut that. Let's paste it over here. And then there we go. Remove that declaration because we have declared it up here already. Now let's do the same stuff over here. So if this thing over here is 0 but not x, instead it's y, then we will say that thing is 0 but it's not x, it's y. Else this thing would have happened. So Control C, Control V. There we go. Oh wait, Y. Okay, so let's remove that. And then just one more. If this thing is 0. Oh wait, I almost forgot. It should be double equal signs. There we go. Alright. There we go. Paste it over here. Now distort Z. There we go. So if that thing is 0, then there's no need to calculate that. It's just all 0. There we go. And then else it would have been this. So Control X, paste, tab. There we go. And then we don't need this. So we have this. So it should be good. Also, we are going to do the same thing for normal extrude. So for normal extrude, it's actually based on norm distort amp. So let's do that. So if norm distort amp is 0, then do something. Else do something. So in this case we need to like get our variables ready. Normal extrude. So we have that. Now, first we have the first pass. So that's a fixed 4. And then afterwards we have these numbers. Oh. Huh. Okay. R, G, B, and then A. Also semicolons all over the place. Oh, also before that, yeah, we have semicolons. Alright, good. Alright, so we have these. Once we get the distort power, then we will say distort pass 1. And also distort part pass 2, which is actually the final result we want, because afterwards it will get used here. So let's see. If it's equals to 0, then set them to something. So let's get rid of that. Let's get rid of this. There we go. Alright. So we have that. Pass 0, what it does is getting a color from texture, in this case normal extrude. So basically it's gonna be like float 4, and then it's like equivalent to like getting nothing. For power, it's also nothing. It's also nothing. It's also nothing. It's also nothing. Pass 1. So pass 1 is a float. Alright, let's see. That is to collect them. But you know, norm distort amp is 0, so this whole thing's gonna be 0 after all. And then norm distort pass 2 is a float 4, and because that is 0, so everything's gonna be 0. So it's a float 4, so float 4, all 0. Otherwise, these things over here would have happened. So let's cut this thing and then let's just paste it here. Also, let's give this a tab. There we go. Now let's remove this, and then let's remove that. This, this, and that. So yeah, here we have it. Now, whatever it do, it will always need these. So, anyway, let's hit save, and let's head back here. Oh, well, okay, let's see what it says. What does it say? If statement conditional expression must value to a scalar. 1298. Huh. One, 298 over here. Alright. If axis distort x power. Axis distort x. Oh! Wait, is it? Let's see, what is this thing? So, let's split that. Let's see. Up here. There we go. What is this? Axis distort x power. Oh, it's a vector. It's a vector. Okay. It's a vector. Well, one way to do it. Oh wait, let's split again because we have this like self-made function to calculate the magnitude of a vector. However, the problem is that thing is a vector 3. So we're going to make a vector 4 out of this. Yep, here we go. So let's copy and paste this. There we go. Vec 4 mag. Take a look at that. Float 4 vect. So let's add a new one. In this case, not Z but W. Meaning, if any of if the magnitude of that vector is 0, meaning we don't have any push along anything, then yeah, don't do anything. So 2, 2, 2, and then vector dot W to the 2, and then take the whole thing whatsoever it is. Oh wait, that looks sus, very sus. There we go, better. And then 0.5. Okay, let's save this. Let's close this. And then let's call forward vec4 mag. So we'll have this if that is 0. So let's have this thing. There we go. And then hit save. And then let's head back to Unity. Use of potentially uninitialized variable z plus 0. Ooh, something's off. X, Y, Z, X, Y, Z, X, Y, Z. Anyway, where did it went? Did I have something crazy going on over here? Let's see. Vertex distortion. If I say 1, we're just doing optimization. Oh wait, it should be a Z over here. So we have Z over here, we have Y over here, we have X over here. So, and then X over here, Y over here, and then Z over here. Alright, good. Let's hit save. And let's head back here. Oh, this may take a while to load. Up there we go. Oh boy. That, as we can see, if we have this, oh, distort amount by default is black. So let's use Perlin noise again. And yep, we have that. And then there we go, by 0 again. So yeah, we have that. Or let's have a 1. And then yeah, we have that. So yeah, optimization is now working. Alright, cool. What else? Norm distort. Oh yeah, let's give that a try. Vertex norm distort. Let's try Perlin again. For now, it's like nothing. Okay, amplitude is 1. There we go. So yeah, we can see it's now working. Alright, cool. So basically, in Quasi Shader, the more feature you want, the more laggier it is. But yeah, it's fair. But at least it's something like it is not always laggy when you're like not using some of the features. So yeah, I hope. But anyway, I'm also thinking, like, should we make another function to compress all of these stuff? Like, it's both good and bad at the same time. Because it's good, it's flexible, yes, but it's bad, it's, you know, a little bit hard to read. But anyway, wait. I don't know, should we do something like, should we like turn all of these into like clip space or something? That might become weird. But we'll see. because we know that this thing over here works for the depth shader, so we'll keep that. And the rest of these are just a lot of stuff. Like, I wish like we can create our own like section stuff, and then we can like collapse stuff. But what else can we simplify? Uh, and then the rest are just whoop. Let's hit save anyway. Okay, so I don't know, should we do a little bit of VR chat stuff? But if I were to do that, oh boy, our frame rate is not going to look good. Anyway, you know what, let's do some shader testing. Instead of returning that, let's go with return slope 4 incoming dot tangent, and then we want x, y, z of it, and then alpha set to 1. So let's save that. Now let's go back here. Yep. If we were to go up here to the very top, we can reset it. And then let's say it's shader testing. So over here we can see, if we were to look from upwards, we can see this thing is like pointing to the right hand side, so it's red. And then once it points away from red, then it's not that red anymore. And once it points, and then once the tangent is like pointing at Z, it becomes blue. And then yeah, if we were to rotate this thing, then we can see when it's pointing upwards, then it's green, which is correct. Actually, we can use this to do like really weird stuff. But anyway, it's working. But what about bi-tangent or bi-normal? So, bi-normal, save. Let's get back to Unity. Everything should be pointing upwards, so it should be green. Oh wait, we're going to have weird colorful stuff going on over here if we were to use bi-tangent. Oh. What's going on? So, bi-tangent. Oh. Okay, so from here, if we were to look at from here, then we know it's pointing that way, so it's okay, red, and once it goes downward, then it's black. And then over here, not quite sure how UV mapping happens on this sphere, but yeah, it's how it works, I believe. So yeah, at least we know it's working in some weird way. But anyway, let's do this. Now the reason you might be thinking is something like, why don't we do like radial stuff? Oh, there we go. Well, there are several reasons for that. Also, I'm thinking, what would happen if we can scale things up and scale things down infinitely? If the answer to that question is actually a yes, then our next question is how? Right, when everything got scaled down to the very grain, then how can we perceive that? Because after all, everything will turn into a piece of weird plane. Perhaps that. But anyway, let's go back from shader testing to channel add. So yeah. Anyway, let's add this. And this is what we have from Fuyoni, yes. But object normal and normal, what's the difference between those? Tangent, binormal, both class, local class. Okay, there. Vertex color? Wait, you can grab that? Is this what vertex color is? Huh. Now, let's say if we can somehow get vertex color, then question would be something like, how can we set the vertex color of something from somewhere? But one thing that I'm very proud of is I ended up with self-definable transform order. So yeah, that is something. Are we going to use depth over here? That will become scary. Oh no. Oh no. Now the problem is when it comes to like depth. Oh boy, this means distortion and distortion and masking will need to have depth. That is something really weird. But anyway, I don't know what kind of transformation we can have, because we have offset, rotate, scale, pixelize, and scale X and scale Y. So what are the transformations we can have? I remember there is this like weird transformation, which is actually a mistake when we were creating the rotation transformation. Like you just change a single minus to a plus, then you have something really trippy. Are we going to do that? That's the question. But also, I'm thinking, should we do something polar? Like, if we say use polar, then it will force it. Okay. Then we can make radial stuff. Hmm. Alright, so let's try to do that. So let's hit save. So, funny stuff, originally this stream is originally planned to have a screen shader or something like that, and now we're ending up upgrading Queasy Shader Tree. From 3.5 to 3.6? Is it? Oh, we're already at 3.6. Alright, 3.7 then. Let's go! So, let's pull out Sai. So in this case, let's keep this thing inside our pocket. Alright, let's minimize that. Now, let's pull out Sai. Whoop. There we go. Because it's actually much easier to like explain like what's going on, or easier to understand what we need to do when we have a good diagram to look at. And it's pretty intuitive most of the time. So let's have something new. There we go. Good. Perfect. Alright. And of course, as a tradition, boop. And now we're good to go. So yeah. Now, question will be something like, how can I draw a circle? Will it work? Like, if I keep on pressing delete, yeah, it will start spinning. Okay, this is weird. But it might work. This is actually stupid, but fun at the same time. No, it will not work. Oh boy. Hey, if we can spin things and then draw it at the same time, oh boy, it will be something like mesmerizing, and we can it's something we can play with though. Anyway, at least we know that will not work. Now the problem comes to, how do we even draw Earth? So, fine, I'ma just ew. Ew. Nah, not gonna work like that. So, let's use this. Binary. Oh boy. Okay, that didn't work as well. Fine, let's fall back to cloud, and then, yeah. Anyway, the main, wait, we don't even need to draw a circle in this case. Oh boy. Anyway, let's set up our coordinate system. So we have that X over here, and then we need our Y. There we go. So we have this. Now let's go with this color. So the main idea is, once we get a point, let's say here. Now the problem will be something like, we need to like figure it out. Like, where will it fall? Over here. Like, it will fall over here. And then afterwards, if we have any extra rotation, then we will just rotate along that. Like, we will let this line rotate along. Like, for example, um, it will fall here, but let's say my final angle, let's say it's here, then it will start rotating again and then end up here. Now you might be thinking, hey, it can be done by the rotation transformation. Well, not quite, because this means that all the other pixels end up on this arc or end up on the same radius will fall into this place, and this means you can have a whole ring of the same color. So if it were to be the rotation, if we have a shift over here, then it's gonna like shift over here. If it were to be over here, then it's gonna be over here. So it's different. So I will call this polar squish, or maybe I'll call this polar sampling. So basically, if you were to like rotate the angle of sampling, you can change the color of the rings. And it might be something interesting. So that's why I have decided to add this thing. Now, first let's solve the first step. What is the radius? So basically we need our point, like center point. So let's call this P0, and then we have this P1, and then let's call this P2. Alright, so we have that. Now P1, P0. First we need to figure it out what's the distance. So basically we need to figure out what's the distance, and then distance. If you take a look at this, P1 is actually UV in, right? So it's actually in UV. Okay, so we know that. So because is that, oh wait, center point is something like user defined. So we can immediately know what is D. So let's get rid of, oh boy, that's a big eraser. There we go. Let's get back to cloud. Alright. So let's say D is over here, and then D is, alright, here we go. So P1 x minus P0 x to the squared, and then, you know, Pythagoras theorem, P1y minus P0y to the square, and then take the square root. So we have that. So that's the first step. Now once we have that, P2 basically just says P2 of x is actually D, and also P2 of y is 0. Now I have to figure, now once we have P2, we need to figure it out a specific angle. In this case, let's just say it's this one. So let's say we end up here. So let's call this alpha. Oh, for formatting sake, we call this one theta. Whatsoever. Now let's see. P0 will, and oh wait, this is a new point. So P2. All right. So let's go for P3. So that's P3, meaning whoops. Oh boy, that curve doesn't look good. There we go. Alright, if I were to buy a pizza one day and I saw this, I feel ya, bro. If one day if I saw a pizza which looks like this, I feel you because I can't do it well. Oh no. Anyway, let's get back to this. So, hmm. Now the problem would be something like, question would be something. Oh wait, let's simplify it. So instead of having this wide angle over here, let's try to clamp things down into the first gradient. Then everything should work fine when it comes to the other quadrants. So, oop, P3. There we go. So, white. There we go. And then back to yellow. Alpha. Now, alpha is given. So, we have this. So, basically, from here to here to here, we have P3x. Wait, not quite. Is, P0x plus P3x. That is something we need to be aware. Oh wait, so P2y is not 0. P2y is P0y. Alright. Have to be careful, it's relative to this point. Oh boy. Alright, very good. So, another yellow one. So, what we have is P0y plus P3y. So, this is what we have. Okay. Wait, hold on. Something's off. Wait. Okay, hold up. Something's off. I feel it. Something's off. Let's not call it this way. Because what I should have done is actually, let's get back to here. From here to here to here, it's actually P0y. And then from alright, you know what? Let's do it from here. So here to here to here. There we go. Alright, and then there we go, and then there we go. So this one over here is P0y, and then this one is P0x. And then let's call this one delta x whatsoever, or yeah, let's call it that way. And then this one is delta y. Now, if we take a look at this, we know that if we look at delta x, now here's where trigonometry comes into play. Oh boy, let's go. We know that, okay. Oh wait, if this is D, then this is also D. Alright, so if we take a look at delta x divided by D, then we know it's actually cos of alpha. This means that delta x is actually d and then cos of alpha. So we have that. Because, you know, we have adjacent divided by hypotenuse. Now, for dy, it's actually opposite divided by hypotenuse. So, dy divided by d is actually sin or sine of alpha. And basically this means delta y is d sin alpha. So now we have this. And then afterwards, then we have P3 of x is actually P0 of x plus delta x. And also P3 of y is P0 y plus delta y. So we have that. Okay. Then hold up a second. Then there is no need to calculate P2. Or is it, let's see. Yeah, it seems like there's no need to calculate P2 because once we have D, we can just like pull D inside and then we just get P3. Yeah, let's do that. So let's put this aside and then let's do this. So, excuse-moi. This also means that we need to like prepare a new vector for all of them. Oh boy, okay, this is gonna be weird. Alright, so let's go down, 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 down until we hit here we go. UV core transform. So let's do this. This will return under another float. In this case, float 2. For UV core transform. Let's call this. You know what? Let's call this radio. So what we are going to need is first thing first, the input is what we need always. The next thing what we're going to decide is our angle, which is alpha. Oh wait, let's also roll it as well. So float, let's call this thing angle, and then float, let's call this roll. So there we go. Okay. Oh, oh, damn. There we go. Alright. So. Oh wait, we also need the center point. So let's go with we need another float. Okay, let's do float. Center X and another float. Center Y. Okay, so we have 1, 2, 3, 4 angles. Oh, no, 4. Perfect for a vector 4. So yeah, we have that. Now let's take a look at this. Let's see. So first, let's calculate the distance, which is float D, or I should say R. Yeah, that should make more sense. Now R, let's have a POW, and let's have a POW again inside. In this case, let's go with input dot x minus center x. So this is what we would have to the second plus another POW input of y minus center y to the second, and then take the whole thing and then square root it. Now we have our distance, or the radius. And then after that, alright, the next thing we need is we need the angle. Float angle current, which is angle plus rho multiplied by time, and then the first one. So that's the stuff we have. And this is actually our real alpha angle. The next thing, we are going to calculate delta x and delta y, so which is over here and over here. So yeah, we need that. Let's see. So float delta x is equal to r multiplied by cos of angle current, and then float, whoops, delta y r, this one is sine or sin, whatever, angle current. So we have that. So what we will return is a float 2. What we will return is a float 2, which is center x plus our delta x. Oh boy, comma just went missing. Alright, there we go. And then center y plus delta y. So we have that. So now this will be ID number 7. So else if current instruction is number 7, then current UV will be forward. Oh wait, this means that we need a new set of stuff. So let's see. Okay, float. Oh boy. Angle. Roll. Oh no. This will get clashed. This will get clashed. Okay. Let's change up some of the names. Current instruction 2. Okay. Current UV. Okay. Rotate. Rotate angle. Rotate roll. Rotate center. And another rotate center. So here we have rotate again. You know what? I'll just gonna copy and paste across the line. There we go. And then now we have this. So the next thing is what we call radio. And then for radio we have radio center X, another float, radio center Y, and then we have another radio. Should be another float, radio. This time is the angle, and then another float, radio, roll. So we have that, and then we have T mode. So let's take a look at this. UV forward radio. There we go. So the first thing is current UV, and then current UV, and then XY angle roll. Okay. So thing is radio X, so center X, and then radio center Y, and then radio angle, and then radio roll. Give them a few space so we can see stuff a little bit easier. And then now we have that. So here we go. In this case, we will need to hit save for now. Now it will not compile. Now we just need to give those stuff names. So, texture layer 1, main, transform, rad, or radio. So, transform. Oh boy, how should we write this? Okay, radial center X. Hmm. Radial center X. Radial center Y. And then we have angle. So radial angle, and then we have radial, and then roll. Or let's see. Let me say just TF and say what it is. So TF shift let's call this offset. Or let's call it TRF. And this will be shift, and this is then this is rotate, and then scale, and then this one is skew. Or let's try to keep it like 8, like perfect length. And center X will call then X. Center Y will be sen Y. Angle will call alpha. Roll. Then we have roll. And it's a vector. With the ID. That's actually a good idea. TF1, TF2, TRF, we have 3 and 4. Scale and pixel. So center X will be 0.5, 0.5. Alpha is 0 and 0. Okay, there we go. So we'll have that. So let's split this. Alright, now let's take a look at this. D-scale. Skew XY. Oh boy, this is something weird. Should it be called TSKW? Since we're only dealing with one file, this. Wait, only one? Then what does this mean? Let's split another one. That one is this, so it should be somewhere around like fragment or something. This is vertex, okay. Texture layer 1, this T skew. Aha! So it's not getting paired up, okay. Does this mean the other one has the similar problem? Yep. Alright, so let's copy, paste the name over here, and then let's do the same stuff. Mask, okay. Mask. Oh, mask skew. Mask skew is fine. Alright, that's weird. What about number 2? Alright, that looks fine. Okay. Alright, let's get rid of that. And let's close this. Alright. Let's take a look. Here we have this. So let's copy and paste this thing. So we have that. Now the next thing is this. Oh, so I almost forgot. Let's split off over here because we changed the text over here. We've changed the text over here. So let's format that. TRF shift TRF rot and then TRF, scale or pixelized, TRF, then we have skew, and then we have radial. So this is for layer 1 dist, layer 1 mask. Oh wait. Dist. There we go. Now let's paste the same thing over here, but instead of main, it is mask. Alright. Let's get rid of those. ERF, ERF, transform mode. Alright. The first one is shift, and then we have rotate, and then we have scale and pixelization, and we have skew, and we have radial. You know what? We can actually use replace afterwards. Okay, so let's do that. Okay, there we go. Or okay. Maybe not. We'll take a look at that. Let me hit copy. F. 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 And F over here. Alright, so let's shift and then rot. And then scale and pixelization. And then skew, and yeah, we have this. Next thing, instead of main, it's this. And then DRF, F, F. F. There we go. Shift. Rot. Scale and pixel. Skew. And we have this. 1, 2, 3, 4. Alright. The next thing is the mask. Well, luckily we have the skew right for the other names. Otherwise, oh boy. To mask red. Okay. This thing. F. 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 And another F. This one we have a shift. And then this one we have rot, scale and pixelization, skew and radial. We have that. So yeah. So we are done for the mask. Now we have Fresnel, and then so we need Fresnel mask. 1, and then Fresnel layer 1 mask T-red. Oh boy. Oh, it's called pause. Wait, if you come to think of it, every transformation will bring you to a new position. Yeah, so let's scratch that. So, not pause, shift, TRF, rot, TRF, scale and pixelization, TRF, skew, and TRF red. So we have that. Now, the next one, Fresnel layer. So Fresnel layer 2, mask, T red, okay, TRF, so the first one is shift, and then the next one is rot, and then the next one is scale and pixelization, and then skew, and then we have rado or radio. Okay, so mask T-rad. Okay, we have that. Vector color. Yep, we need a mask for that one as well. And vector color layer 1 mask T-red. So vector color layer 1 mask T-red. Okay, let's copy and get stuff ready. So TRF F F F. There we go. There we go. Pause. Is shift, and then we have rot, and then pixelization, and then we have skew, and then we have that. The next one is this one. Layer 2 mask. Alright. F F F F. Underscore, 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 underscore. Shift. Rot. Scale and pixel. And skew. And then we have that. Okay. The next one is number 3. Okay, F, 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 F. And then underscore whatsoever. Underscore. Shift. Rot. Scale and pixel. And skew and radio. Yeah. The next one is this one over here. Number 4. F F F F. The score upwards. Shift, rot, scale and pixel, skew. Alright. There we go. Skew. Boop. Now this one is the glitter layer. Glitter layer, T-rat. Alright. So TRF again. And then we have skew, and then we have pixel, and then we have rot, and then we have shift. Shift with an F, okay? Calm down. Shift with an F, okay? I didn't miss that, alright? Anyway, oh boy. glitter layer is done, and then now is vertex distort. Let's go. So this one is axis. Distort. X T-rad. Alright. Distort X T-rad. Let's copy this thing. Alright, now TRF, F, oops, F. Shift, rot, scale and pixelized, skew, and radial. So now we have that. And then the next thing is this. And it's Y T-rad. Okay. F all the way down. Underscore all the way up. Shift, rot, scale and that. There we go. Radial. There we go. Here we have that. So we have Y T-rad. And then now this one is Z T-rad. So Y T-rad and X T-rad. Alright, we have that. Nice. Here F, 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 F all the way. And then underscore. And then shift, rot, scale and pixel, skew, and we have that. Yep, and next one we have this. Normal, extrude, main, T-rad. Normal, extrude, main, T-rad, and we only have this one. Okay. So F, 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 F. Oh wait, no. That one's completely fine. And then we have shift for this one. And then a few more changes down here. Oops. Skew, scale and pixel, rot, and then shift. Yeah. So 1, 2, 3, 4, 5, 6, 7. Oh boy, we have 7 operations. Okay, T-rad. So that's in here. Oh wait. Extrude with an E. Capital E. And then, yep. Alright, then we are ready to declare them and then use them inside the codes. Before that, let me hit save. Don't want to lose any progress. Alright, the first thing to deal with oh wait, one thing to keep in mind is we need to lag. Oh, there we go. Remember the order of the entry of the inputs. So let's split this and put this thing down here. Alright, now let's go. So first thing first. Axes, this toward axes, this toward x t rad dot x, and then let's copy and paste this thing across. Wait, hold up a second. We haven't declared it yet. Like up here, we haven't declared it yet. Okay. It's a vector axes, this toward x t rad. X t rad. Copy and paste. This one is y, and this one is z. Okay. One more vector normal extrude main t rad. There we go. Yep. So let's get back here. Let's copy, paste, dot y, paste, dot z, and paste, dot w, right? X. We also put that in order. If that is the case, then we're in good shape. You know what? Let's split. Let's see where it is. We need to go up to the parameters. There we go. Radio. Center X, center Y, alpha, and then roll. Yep, perfect. So it's just like X, Y, Z, W all across. So we don't need that. Alright, cool. Oh wait, let's have the coma over there as well. The next one. This one is Y, and then Y, Y, and Y. Y. And then we'll have Z on this one. Oop. Alright. Z. 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 C. There we go. Alright. And then it should be all good. Now, for norm, okay. So, normal extrude main T rad dot. Copy that. So Y, and then X, and then Y, and then Z, and then W, and then we have that. So that's for normal distortion. So we have that. Okay, here we go. Vector, texture, layer 1, main, T, rad. So we have that. The next thing is this. So vector, texture, layer 1, this, T, rad. Next one, we have vector, texture, layer 1, mask, T, rad. Oh wait, with a capital T. Just need to make sure we have that as well. Capital T. Alright, good. So, this is the main one. Distortion one. Okay. And then, yep, cat. Next one. The vector. Texture. Layer 2. Main. T red. Here we have a vector, texture, layer 2, dist, T red. And then finally this one, vector, texture, layer 2, mask, T red. So we have that. Now, press no. Alright, there we go. So, vector, press no, layer 1, mask, T red. Press no, layer 1, mask, T red. So we have that. Next one is the second one. There we go, which is another vector as well. Press no, layer 2, mask, T red. Vector color layer, and then we have this. Alright. Vector CR or color layer 1, mask, T red. So we have this, and then we can just copy and paste across the whole thing. So copy, and then we'll paste it over here, 2, and then we'll paste it over here, and that will be 3. And then this one over here, this will be 4. Alright, mask, T-red, alright. Light map, glitter layer, let's paste that. Glitter layer 1, main, T-red. And yep, we're ready to copy and paste those stuff. So, texture, layer 1, this, T-red. Dot, and then just copy and paste the other stuff. X, Y, whoops, Z, and W. That's the first step. Now, another thing. This one is number 2. X, Y, Z, W. Alright. And then we can keep on going down here. Oh, there we go. Paste it. Turns out this is 1, and then mask. So we can copy and paste this thing across. X, Y, Z, and W. And then, yep, another one would be this one. layer 2. Let's copy and paste this thing. X, Y, and Z, and W. So we have that. Now we have this. Texture layer 1 main. So texture layer 1 main T red. Okay, X, Y, and then Z, and then W. And then for another one, oh hold on, this is that one. Okay, the long process, and now we end up here. Paste. It's a 2. Copy. X, and then Y, and then Z, and then W. So X, Y, Z, W. So we have that. Alright. Two. Alright, cool. Alright. And then afterwards is just a whole bunch of stuff. Alright. Oh, now we have this. Okay, cool. Vector CR layer 1 mask T red dot. So let's copy and paste this stuff. X, Y, Z, and W. Alright, now we have that, and then now we need this. So paste it over here. Number 2. And just copy that. So we have X, Y, and Z, and W. Okay, now move on to the next one. This one is number 3. Copy. Alright, X, Y, Z, and W. Just need to make sure it's also X, Y, Z, and W, and also X, Y, Z, and W. Alright, good. Alright, cool. Next we have this, which is number 4. Copy that. X, Y, Z, and W. So this, we have that, we have this, we have that. Yeah, we have that. Alright, I think we're good. Alright, and then we have Fresnel. We're not done yet, but let's hit save. Don't want to lose any progress. Okay. So, Fresnel layer 1 mask T red. Dot X dot Y dot Z, and dot W. Should look good. Okay. Next one is Fresnel number 2. So let's paste that here, and number 2. And then let's just do this. Dot X, dot Y, dot Z, and then dot W. Or sometimes Zac, I don't know. Fresnel layer 2 mask T-Rat, Fresnel layer 2 mask 2 mask 2 mask. Alright, good. X, Y, Z, W. Let's go. Boop, boop, boop. Nope. There we go. Alright. Glitter layer 1 main T-Rat dot. And then let's copy this thing. X, and then Y, and then Z, and then W. X, Y, Z, W. So we have that. And then glitter here. Wait. What we have is glitter. Alright, cool. And I think we're finally done. Alright, hit save. Now, let's head back to Unity and see how it goes. Probably gonna end up pink. There we go. So let's see what do we have. Undeclared identifier exit distort X T-Rat. Eh? That looks right. 1353. One, 3, 5, 3. Axis distort XT red. That's how we name it. Ah, distort. So let's check for others. Oh, this one is also distort. It didn't catch the others as well. Okay, there we go. All right, let's hit save, and let's see what else. This may take a while for it to import. Yep. There we go. Alright. So, okay. To see this new feature working, it is hard to see on a sphere. So we will not use that. What we will use is a plane. So we have this. Yep. There we go. So, texture layer 1, texture layer 2, not gonna use that, not gonna use glitter layer, and yep. The first thing first, we're gonna use that, and then we are going to use number 7. Finger crossed. Woo! Yeah, baby! 0.1. Woo! Look at that! Yeah! It looks amazing. Wow, it looks amazing. Just look at this. Just look at this. And then now, let's just give it a little shift, so 0.1. And then after that, let's go with 1. Oh wait, we should go with 1 first. Then we'll... Oh. Hmm. Interesting. What will happen if I go with 1? Then it will definitely go crazy. But if I say only just 1, then yeah. But anyway, let's go with this. And now let's go with 7. Or maybe 7 first, then 1. Oh wait, that is actually... Because what is happening is number 7... Okay, what number 7 will do is... What number 7 will do is... It will take whatever is the same radius from that and then collapse that to a single point. And then once it gets collapsed to a single point, then if we do a rotation, then this means this whole thing is gonna end up the same. So yeah. But it's actually quite fun to see it's working. For example, like now it's like 7 and then 1. So what we will have is, if we were to like perform number 7, what we will have is whoops. What it will do is it will take this whole arc and then just like put this inside a single point. And then once we do a shift, then it will end up here. Or okay, hold on. Let's take a look what's under the hood, because I've forgotten how it actually works. So let's take a look at this. Current instruction, temp mode. Oh, okay. So instead of 7-1, what I should done is 1-7. Okay, fair enough. But actually this looks cool, I have to say. Wait a second. So is this how we get to scale things infinitely? Now come to think of it. But if I were to like show you what is going on, then yeah, no problem. To see how it fully works, let's go to quasi specific, quasi temp, and let's make another one. So which is temp 1. Now let's duplicate another one. So let's duplicate. So now we have this plain 1. Z in this case -1. That is not enough. -4, -5. And then this one will just move upwards a little bit just to cover that thing up. There we go. And then now let's move temp 1 over here, and then let's see. Let's see. In this case, we will only do 1. Now, if I were to like shift along that, then it should be 0.5. No, alright, negative 0.5. So now you can see how, like, what it's doing. Like, if I were to divide that by another 10, you can see it's like taking colors over here. And then just, no. Oh boy, this is beautiful. So yeah, we have this new feature. Yay! Now, fun stuff would be something like if I were to start spinning this thing instead of like shifting it. So, 1-7 can be done. 2-7. So let's have that, and then let's have 0.1. And then so this one over here, let's have number 2 working. 0, and then 0.1. So now we have this. If we were to like offset it again, we like you can see it's grabbing the pixels over here again. Like you can see that. Oh boy, this is so beautiful. Just look at this. Just look at this. So yeah, now we have this like weird and new transform operation. So yeah, were we still at 3.6? Because this should be oh boy, I don't know. I've lost track of that. But whoa, thanks for the follow, Kingslayer. Yeah. Anyway, 3.6. I forgot that. So let's head to GitHub. Let's head to GitHub. Now, the way to get there, which is go to our website. So, just in case if you need the link, let me copy and paste that into the chat box so everyone can go to that link and grab that thing. Let's see. There we go. There we go. Copy and then head back to Twitch and then now. Let me find this. Up there we go. Oh boy, I better mute myself over here. And then paste, paste. So that thing in the chat box, that's the link to our website where you get to have our GitHub stuff. Oh, so once you got here, you go to Art 2009 and then you go to the right page twice. So there we go, and then you go to virtual reality, which is this one. Once you click here, it will bring you to another page, and you scroll down, then you press this button which brings you to GitHub. And so this is where you will get Queasy Shader. This may take a while to load, and here we have. So here we have it. Queasy Shader is down here, but of course, along with other shaders we have written on stream as well. for example, the depth shader, which is from yesterday, and we have the Voronoi shader as well, from a few days ago. So yeah, and after the stream, I will update this thing and then get this thing to GitHub. Or how about I'll do it now? So, oh wait, the reason I opened up GitHub is because I want to check the version number of that thing. So let's take a look at this. So that if we were to like scroll down, we can see it's 3.6, so it should be 3.7. There we go. So we have that. What else? I don't know. But looks decent. Anyway, that looks fun. Alright, I might just like minimize this stuff. Also, there is this like one thing I would like to experiment with. So let's focus this thing back at the center with no transformation at all, and then just how about let's say this is at 0 and this one is like 0.01, and then also on top of it, and then we will say it's 0.5. There we go. So now we have this. So now we can demonstrate one thing, which is something like the angle rolling for radio. So 7. Alright, zero that out. We are going to focus on number 7, and it's going to roll with a speed of 1. So, to be honest, at this point I have no idea which radius it is like, or angle it is like sampling now. But it's doing its job, yeah. You know what? What I'm going to do is to have wait, this is temp. So temp 1 should spin, which is number 2. From here, we can't see it though, but let's change this to negative. Let me see it here. No. Oh, this one. I have a feeling it's somewhere else over here. Like this one is 0.1, and then this one over here is also 0.1 as well. So they're actually spinning at the same rate. Problem will be something like which one it is sampling though. Oh boy, this is one of the hard parts to do by eye. If you think of it, I'm thinking it is sampling this point. Or is it? Or maybe I should have like let them rotate in the same direction. So maybe temp 1 needs to like spin at 0.1. You know what? This picture over here is a little bit complicated to look at. So, can we choose another one? Let's choose hibiscus chunk. And then temp should be another hibiscus chunk. Oop. Okay. Like the moment when we see green. Oh. Oh wait, I think it's this angle. I think it's this angle it is collecting. Like, if we were to like see it over here, like, yeah, we can see it. So yeah, that demonstrates it. Oh boy, this is a weird morphing effect. But yeah, this is what we have now. Okay, so we have this. Oh boy. Let's hit file and then let's hit save. How long we've been here? Oh boy. 3 hours. Oh boy. Okay, I also have to work on VR chat stuff as well. Now the only problem is, if I were to work on VR chat stuff, the stream is going to be extremely laggy. So I'm going to do that off stream. However, after the update, I might do a little stream as well, just to keep everyone up on like what's new, what are the updates, etc. So yeah. So what I will do after the stream is I will upload the new version of Queasy shader and the new version of the depth shader onto GitHub. So that's what I would do after this stream. So, yeah, if you're watching this stream to the very end, thanks for watching, and I will see you in the next stream. Bye bye.